Hello everyone, my name is Nour J and Agouf. I think that most of you know me by now. I will be presenting a new visualization. Well, it's an enhancement of an old visualization that is called class blueprint. Who is already familiar with the class blueprint visualization? Okay. For those who don't know, it was first created by Michele Lanza and Stéphane Ducasse, with whom I had the pleasure to work with on this new generation, plus my supervisor, Anetien. Oh, sorry. It is a representation of static data of classes in object-oriented programming. It is intended to give an overview, or what we call a taste of an understanding of the class, where the understanding comes from the classification of methods and displaying the call flow between the methods. Now, as you can see, here is the original visualization, which was first created in the early 20s. It is based on 5 layers. We have the initialization layer, which is on here. I don't know if you can see it, which holds initialization methods, or what we call in Java constructors. We have the externals layer, which holds the public interface of the class. We have the internals layer, which holds the private methods. Then we have the accessors and the attributes. Of course, the visualization is based on a node link diagram and colors attributed to each method, where each color represents a method type. Now, to present the new visualization, let's first explain a little bit the layout. First, we prefer to leave the initialize externals and internals layer, and then the idea was, we said, okay, why not merge the accessors and the attributes layer into one layer and have the attributes here, and then have the accessors protecting the attribute node, as we will see later. The next idea was to separate the instance side, basically show the superclass attributes, which is a concept that did not exist in the original version. Next. The next idea, we said, okay, why not divide the instance side from the static side? Basically, we have what is static on the top, and everything that is instance side in the middle. Last and not least, we have the dead methods, or the dead attributes, or what we call the dead code. We chose to add this layer because dead code hinders the understanding of the real responsibility of the class. Like that, we lose some time reading code that we will not be using. So just a quick summary so you can remember the layers. What we have on top is static. What we have in the middle, that is instance side. What we have in the bottom, that's dead. Then we connect, well, we add to each layer its nodes. And of course, we connect these nodes with the node link diagram. You also have to notice here that each node has 2 metrics. For instance, the method node, the height represents the number of lines of code. You cannot really see it here. The width represents the number of invocations. For the attribute node, here, the height represents the number of external accesses, and the width represents the number of internal accesses. Next, in the visualization, we chose to give a border of the node a semantic information, which is not very common in visualizations. So the semantic information we want to show here is whether a method is unique in the system, meaning that the method has only one name in the system, or a method is commonly used or frequently used. For instance, in Faro, we have, in a project, we can have several methods with the same name initialized. And such methods, for example here, in the initialize layer, we have a method called initialize with very, very thick border, which means that there are several methods with the same name. Next, what we added in the new generation of the visualization is the complexity of methods. Basically, methods with very high complexity have a red border. What shows the red color, this is because we wanted to attract the user's attention to complex methods. Next, we wanted to, as I said, to show the superclass attributes. For instance, here, the difference between the green and the blue is that green attributes are attributes that are also called in the subsystem. Next, we have the accessors. As we said, the accessors are protecting the attribute node. For instance, here, this is the attribute, this is the setter, and this is the lazy initializer. Here, for instance, this attribute has only one setter but does not have a getter. And this attribute has no setter, basically no accessor. Next, the other concept that we added into the visualization is to show the trustability of the class. The trustability in terms of testing. So what we added is the green annotation here. As you can see that this class is not really tested because in the whole class there is only one method that is tested, which is only this method. Here's the green annotation. Next, we added another shape into the visualization. This shape is not also common in visualizations. Is the rectangle with a little square inside to show that this method in cyan is abstract. That's why it's colored in cyan. And it also has a heart inside. This means that this method is abstract, but it is also re-implemented in the subsystem. Next, we attribute to each node a color. So basically, I did not show the legend here to not distract you because there are so many colors. But in the real visualization, you can see the legend. For instance, here, orange is for extending methods. Brown is for overriding methods. Yellow for delegation, etc. And black is for dead code. The visualization is interactive in the sense that a left click shows the outgoing invocations. For instance, here I clicked on this method node, and this highlighted all of the other nodes, meaning that this method calls all the red ones, attributes and methods. A right click shows the incoming invocations here. A click on this method shows who is calling this method, all the green other methods. Next, if you want to see a little bit the code, you can have a mouse hover plus shifts over the method node. Or if you want to browse the method in the system browser, you can double click. So this is a little recap because this is the initial visualization. As you can see that it had 5 layers, and now we extended the layers. We also extended the colors. Now we show static versus instance side. We show superclass attributes. We show the cyclomatic complexity, dead code, lazy initializers, etc. Yeah, I'm done. Finally, we proposed an enhancement of the visualization based on 26 participants and 19 projects. And the paper was accepted this year in VSOF 2022. Thank you.